A linha de pesquisa dela é em mobilidade elétrica. Ela também faz pesquisas sobre estratégias de controle avançado e conversores de energia. E hoje ela vai estar ministrando para a gente essa aula sobre mobilidade elétrica. So, Professor Margarita, thank you very much for your presence. It's a pleasure to organize this activity with you. And feel free to start the presentation.
Okay, thank you. I hear that Moira present me, but I'm going to introduce also myself. Wait. Okay, this is my home university. This is Universidad Técnica Federico Santa Maria here in the picture. I'm from Chile, and I think Moira say everything. I'm also an associate editor of the journal of IEEE, Journal of Emerging and Selected Topic. So I think that is all. I don't know how to move this. Perfect. Okay. So this is a short presentation. It's more a brief of electromobility and assessment with electric car and traditional combustion car and probably hybrid car. So it's what are we want to get, how works the cars, and why electromobility is the future, okay? And it's passing now. So to start, the challenger, what is the motivation to start with electromobility is the transportation, okay? So in the beginning, we try with hybrid cars. So for example, the hybrid BMW. So this is an hybrid car, an example. And what is the characteristic of the hybrid car? They has an ion lithium battery. They has 2 hours for 80% of charge, has electric motor, and the electric motor has the power of the 131 HP by 250 nanometers, okay? Newton meters. And the maximum speed that this car can get is 250 kilometers per hour, okay? And get the 100 kilometers per hour in 4.4 seconds. But how works the hybrid car? What is the difference? What is going inside? So this is a picture of the inside of the hybrid car. So here the blue one is the combustion motor and the green one is the electric motor. So you can see the difference of the size and consequently the difference on the weight. And this gray box is the battery stock, okay? So this is the battery for the electric motor. So when you start in the acceleration, you get the energy from the battery to the electric motor. So the combustion motor is not working when you're parking and you start to moving in the acceleration, and only the electric motor is working, okay? Then you get the speed in a point that you can include the combustion motor. So you have the first meter of the acceleration only with electric motor. So this has the next characteristic is silence, because electric motor, I don't know if you can hear an electric motor and a combustion motor, is really silent. So when you start to move, the vehicle is silent, has energy not from the fuel, only from the battery, and every time has the same speed, okay? So because this is electronic control for the electric motor. Then when you are in the steady state mode of the conduction, the electric motor is off, so it's not working, and only work the combustion motor when your speed is continuous and all work fine, okay? So when you are in a steady state, you use the combustion motor. But then, for example, if you need to go in acceleration, the maximum acceleration on everything in your conduction mode, not from the parking, when you are from the steady state, so you activate also the electric motor. So you have the combustion motor plus the electric motor. This is not the beginning of the conduction, is when you are in the steady state, okay? And you get the maximum acceleration of the car. After that, for example, if you need to reduce the acceleration, you need to apply the brakes. So both motors are off, but you activate the brake, and the brake can charge the battery, okay, with regenerative brakes, you know. So this allow to charge the battery when you are in natural or in the conjunction mode. When you need to brake, you can recharge your battery. For that reason, in an hybrid car and also in an electric car, the battery has time of charge and discharge, charge and discharge, okay? And when you are in the stop, in the parking, both motor, okay, is off. And when you need to start again, only the electric motor start. Okay, that is how work an hybrid car. That was the first step in the transition from combustion to electric car. But now we need a 100% electric car without combustion motor. So this is an example. This is a Tesla. If you can see here the inner of the car, you can see the motor. This is the motor. This is the converter, and this light gray is all battery. All this plate is battery. Okay. So we have 3 induction motors. So in this case, we have 2 in the wheels of the back, 1 in the front, and this is the converter for the boot. We have a power of 500, is 5 times the hybrid, okay? This is 500 by 900 Newton meters. Of course, you also have a lithium-ion battery. This is it's not the best battery. You know, the best battery today in the research in the lab is the titanium battery, but it is really, really, really expensive because titanium is a really, really expensive material. Okay, so it's not possible to get a titanium-ion battery for cars. Okay, the more cheaper and better battery for the cars today is lithium-ion, okay? And you have here, in this particular car, you have 16 modules. This means 7,000 of battery cells, okay? It's a lot. It's, let's say, it's all the phone of the car. And you can get, from this battery, 90 kilowatt hours. That is the energy that you can get from this battery. And you can get the 100 kilometers per hour in 2.8 seconds. It's almost the half of the hybrid car. Okay? And this is a point that, okay, the top speed is similar, 250, 249, okay? But this is a point. In the speed cars, in the this kind of car, when you're going to see this car running in a circle, this car get the 100 kilometers per hour in 2.5 seconds. This is the maximum faster acceleration that you can get with a combustion car, in an aerodynamic car, in this Culmin mechanical engineering car, okay? But now the Tesla, in a city car, in a car that you use every day in the city, you can get almost the same speed acceleration, almost the same acceleration in 2.8, 2.5. So the engineers say, is this really fast or not? How this really work? We need to test this. So they get this. I don't know if the audio is going to hear. So they put normal persons in an electric car and test acceleration.
That's 60. You don't expect it, right? Is that me?
That's awesome. insane.
Yeah, go ahead, press it and see.
I'm not going to throw up.
I hope not.
Okay, that's enough. Okay, I got it. Holy
So yes, the acceleration is really, really fast. And it's compared with acceleration car in a car speed circuit. So what is this possible with an electric car? It's because the characteristic of the electric motor is a really fast control. Okay, this is the torque, this is the speed, this is the current. So you can see when you are in the maximum speed, okay, this is, if you can see here, the torque is in a steady state is null. So this is only without load. For that reason, it's more fast than in the electric car because the car has a natural weight. Okay, I don't know, 1,000 kilograms. I don't know. For that reason, this torque is only with a motor with the rows of the motor. Okay, but by the way, this is to show the change of the speed. If you are in the maximum speed in one direction, and then you instantaneously want to change the maximum speed in the other direction, this is the change in the black line. So you can see it's really fast. This is in milliseconds. Remember, we have not torque. So it's really, really fast, the control that you can get with an electric motor. The combustion motor, we're going to review in the next slides, but in a combustion motor, you have really slow dynamics because depends of the heat of the motor. Okay, for that reason, it's not easy and it's not thing that you need to do, or you never try this in home or in your car or in your parent car, because if you want to change instantaneous the maximum direction in one side, for example, from the front, and you need to put reverse march in a combustion car, it's not possible. You can see some videos, Miss Buster tried that, and it's no, you're going to broke the car. Okay, don't do it. And this is, okay, this is in Spanish, but a blinket of the eyes takes only 304 or 400 milliseconds. So this is in the lab more faster than you blink in the eyes. So you only can measure with an oscilloscope or with a special instrument. You even cannot see when the motor changes the maximum march. Okay. Okay, so for that reason, the engineers say, okay, we have the Formula 1 with the car's combustion, so why we don't have a Formula E, that is the racing for cars only electric powered? So this was doing Formula E, that is racing for electric cars. And there was, of course, organized for the FIA, is the, the international organization for this kind of racing. And in 2014 was the first championship of this racing. Okay, and this is the companies that are involved in the construction of the cars and in this racing. And these are the different places where it's taking the racing. And in 2018 was placed here in Chile. Okay, I don't know if in Brazil, I think no. Okay, but that is before to get electric car for our people in the street, we have Formula E, okay? Because that is more important. And that is a point, you know, remember when I talk about hybrid car, the electric motor has not noise. And one characteristic of this racing is the of the cars, okay? Because you only are in your seat and seeing the cars moving, but if you are not here on the car, it's not really interesting to see this racing. So this car, this specific car, has a configuration in the control or to add sound to the car, you know, because the car has not sound naturally because the motor is really silent. So they add the engineers add sound to the cars to sound these characters when the car is moving to the rising, okay? This is one interesting point. Okay, so continue with what we are doing so in electric cars. So this is a Volvo, this is not a Tesla, but has similar characteristics. And okay, this is in Spanish, but I'm going to translate. From the last 2 years, in 2019, the Volvo car, the company, Volvo Car Group, start to produce only cars with electric motor and hybrid cars, okay? So they don't build more combustion cars, only hybrid or electric. In Spain, they don't allow to sell combustion car starting in 2014. And Denmark, Ireland, Germany, what is the Holland, they don't allow to sell cars of combustion start in 2013. And Norway, they has this provision in 2025, so in 4 years more. And in Chile here, we hope that in 2050, almost the 40% of public transportation is going to be full electric, and the 100% of public transportation, this is the 40% is for the personal, what the car you going to sell by yourself, and this 100% is the, you know, the, I don't know what is the name in Brazil, but the bus, the transportation where all the people can use. Yeah. What is a challenge of the transportation? How to charge the car, you know? One characteristic we're going to review in the next slide, but one characteristic is that is really slow, the charging of the electric car. So, and if you are thinking about the cars today, the way to use, almost the 80%, I don't know, if you are travel a lot, probably 75% of the time of the car is parking. You only use the car the 30%, 20%, or if you are not traveling too much, 10% of the time. You use to travel from one point to the other, but you are parking a lot of the time here, and then you travel from that, and you park a lot of the time here. So one idea is, why don't you use generation in the parking? For example, to get these solar panels, photovoltaic energy, to charge the car when it's parking, because a lot of time the car is parking. And also in United States, they have this, you know, supermarket parking with a roof of the parking for the car. This roof has a photovoltaic panel. So when you're parking in United States, that is a project. I don't know if they still course the project, but I participate in this project. Is for charging the car when you are parking in the supermarket, for example, in the mall, I don't know, whatever, when you're going to buy something, because you stay a lot of time and you can charge and you can go again. Because also the autonomy, the car, number of kilometers that you can move with your electric car with the full charging battery is not too much compared with the number of kilometers of combustion car. For example, a 40 liters combustion car, that is a medium car, combustion car, they can move around 600 kilometers, 550 kilometers, around that. But an electric car, the better electric car is a Tesla with the battery of Tesla. That is the S3, I think, is the Tesla 3. It can move 500 kilometers, but has 7,000 battery cells. But the BMW or whatever other vehicle, there around the autonomy is 300 kilometers. So it's the half of the minimum of cars, combustion cars. For example, family car that is a more bigger car in combustion has around 700 or 800 kilometers that can move with the full tank of combustion. But today there are no one electric car that with a full charge of battery can move 700, 800 kilometers. Okay, the maximum is around 500 or 600, the maximum. So to move in a highway, the electric car, for example, has this slow way. This slow way do run slow, of course, because it's the name of the way. You run slow, and this has photovoltaic cells and induction charge. So you are charging your car by induction. So you are running by this, and you are charging your car. Okay, that is in what is the name of this? In the Holland, if I remember good, Holland. In Belgium, Holland or Belgium, okay? And they are trying this. So now we're going to compare the electric car versus the combustion car, okay? When the electric car starts in the mind of the person, this starts in 1,000 or 1,900. So it's older than, it's older than the combustion car. But what happened? Why we start with electric car and then we move to combustion car and then again with electric car? So in the beginning, if you can see, or you can think about that, the electronics are too high and weight. So the electronic is the way to control the electric car. The battery are too weight and don't move a lot. So it's only inside of the city and small cities. And for that reason, the person say, okay, we have a combustion car and this work really easy compared with the electrical in that years, in the 19th. And this can go with a lot of kilometers. So the people say, okay, combustion car is better. And today we say, okay, combustion car is not better. Combustion car has a lot of pollution and bad things, okay? So now we are moving again with the electric car. So this is the inside of wood cars. Yeah, we're going to use a Tesla for the model. This is a generic combustion car. So you can see here the main difference. Here is the battery, so the fuel tank. And here, this small one is the fuel tank. This is similar autonomy, similar characteristic in general, okay? So this is the fuel tank. This is the fuel tank. This is the battery, okay? This is the motor, and this red one is the motor. This is the engineer to control the motor, and this, you cannot see, but we are going to see in detail, don't worry. This green one is the control of the motor, and this is all the mechanic to control the engineer of the motor, okay? To make the translation for thermal energy to mechanic energy, okay? And this is only the engine for change to electric engine energy to mechanical energy. Okay, so how works the combustion car? We have the motor. This is the inside of the motor where the combustion is doing. We have the transmission when you change from the heat to the mechanical, the move. And we have the engineer here to move the wheels, okay? Inside of the motor, we have alternator that can change the battery. We have a small battery to do the explosion. You know, we need the electric energy to make the explosion of the combustion. And we have inertial well, this, to facilitate the move. And we have this weight that possible to move this in circle, okay? This is what inside of a motor. This has only 4, in general has 6, is always in pair. And when this explosion occurs, this go down, the move naturally with the inertial and the weight complete the circle, and this up and compress the combustible, and the electric ignition produce the explosion, and this go down, and that is the circle, down, up, and that's move in a circle movement here, okay? And how work the electric car? Okay, this is the inside, and the movement is for the electric motor. So in general, we have in the main cases, we have a permanent magnet motor, so it's a synchronous motor. We have 3 phases because it's a 3-phase motor. We have the coils and the different, I don't know, field that they are inside of the motor, and we use alternate current. And if you remember, and if you can see, the battery has continuous current, so we need to change from continuous to alternate to use the motor, okay? So the brain of the electric car is the converter, is the element that can change the energy from the batteries that is continuous to the motor that is alternate, and that can control the motor with speed, maximum current, frequency, etc. Okay, you can control every characteristic of the motor with this converter. For that reason, this converter, okay, in this case is inverter because it comes from DC to AC. So this inverter has the control of all the car. Okay, if this foul, the car foul. Okay, this is very robust. This is not going to foul. It's really difficult to get a foul in a motor. The only way to foul this is the control of this fouled. Okay, if the control of this foul, the motor is going to have a problem. This inverter is rectified when you are regenerate energy from the motor in a regenerate break to the, in this case, is a rectify from the AC to DC to charge the batteries, okay? So for that reason, it's a converter. Sometimes it's an inverter from one side, and sometimes it's a rectifier in the other side, okay? So we're going to compare the both motors. So we have the electric motor. In this case, the weight is around 30 kilograms. And in the combustion motor, we have around, in a typical, 180 kilograms, okay? The power, in this case, is almost 270 kilowatts. And in this case, the power is 140 kilowatts. So the relation between weight and power of every motor in this case is 8.5, and in this case is 0.8. So this is almost 9 times this motor in weight by power. So this is really, really lightweight compared with this, and really small. Also in the size, in the space that used is small, okay? And other characteristic is refrigeration, you know. This case, this motor is combustion, so you have explosion inside, you have really heat inside of the motor, and you need to you need to dissipate this heat, and you use this really huge radiation to dissipate the heat of the motor. In the case of electric car, also get heat, also is has some heat inside because has losses, but it's really small compared with this. So only the space in the axis, only the space inside of the inside of this exit here is enough to refrigerate the motor. So you will not need more additional. And also the construction here, I don't know if you can, I can write here. Here in the outside, you have some space where the air can flow, so that is enough. But here you need a really big refrigeration method, okay? Okay, so, and also, if we compare the efficiency of both motors, okay, the combustion motor has a range. I don't know if you drive, but you almost every time need to reduce the consume of the combustion around the 2,000, 4,000 RPM, okay, revolution per minute, because this is the RPM of the motor, and we get the maximum efficient around here top, that is around this, and we get sorry, this is around 2,000, it's more than this, and it's less than 40%. It's really, really inefficient, okay? It's really, really bad. And this is the best case, okay? You know, there are some combustion motors that need, I don't know, the maximum engineer that probably in the lab is 60%. So 60% is still bad, but the worst electric motor is, I don't know, 90%. But in general, the electric motor has upper 90%, is around 95, 98. It's really, really efficient. And you can get this efficiency in the minimum, okay, not really in the null, because close to the null RPM has a little bad efficient, around 80%, because has problem with low speed. Some motors, some electric motor, you know, we have 3 different electric motors: DC motor, induction motors, and synchronous motor. So induction motor is not really good for low speed. If we use synchronous motor, it's more good for every speed, okay? But it's still 80%, 85, 90% is still really, really good compared with the combustion, okay? So, but in general, it has 95 and upper efficient in a really huge range of RPM. So that is one point for electric car. Okay, that's all that we talk here is point for electrical. That is electrical is really, really better than a combustion. Okay, we going now with the time of charge for every car. In the case of combustion, is less than or around 5 minutes. In 5 minutes, you have full charging the combustion car. The fuel tank is full charging. In the case of electrical, in a fast charging station, so not in a normal station, in a fast charging station, you need more than 1 hour to get the full charge. It's around 1.5, or around 2 hours, depending on the car. But in a fast charging, you get 1 hour, and it's not really the 100% of the battery. It's around 80, 85%. In the fast charging, they don't charge the full charging of the battery, okay? So this is a point for the combustion car. And also, the density of the energy of the batteries and combustion is really different. You can see the combustion has 2,000 watt-hours energy per kilogram of combustible, of fuel. And in the case of the electric, we have 250 watt-hours. So it's really, really, really small compared with the combustion. So this is a point for the combustion car. For this reason, we need a really small tank, and here we need a lot of battery, okay, to get similar or almost similar energy available to the car. So we need a lot, really, really a lot of battery. In an electric car, if you're going to work one day with an electric car company, you need to think where we can put more battery. Okay, we put battery in the doors, battery in whatever, okay? Because we need the batteries. We need the energy because the density of the energy, of the electrical energy, is really bad. I don't know if you know this, in the every energy, you have three characteristics of the energy: the storage of the energy, the use of the energy, so when you want to transform the energy in a different energy, and the transportation of the energy. Electric energy is really, really good in the transportation. You know, you use only cables and go with one city with the other with minimum losses. And really, really good in the use. The efficiency, you can see recently, the efficiency of some motor is around 90%. The efficiency of electric energy transforming in other energy is really, really good. But the storage of the electric energy is really, really, really bad. Okay, it's not really good to get a storage of the electric energy. For that reason, it's the main problem of the electric car today. So this, if you can imagine, this has 7,000 battery, is really weight and solid. Okay, what is the problem with, okay, this is a small, we are not talking more about this because this is, okay, good. This is a good point for combustion. They win this point. But what is the problem with this, a lot of weight storage energy? The problem is when you have the friction coefficient, because you have more load in the car. Even if you are only passenger, the conductor is the only passenger of the car, you have more load in the car than in a combustion. So the combustion can get this curve, but the due of the friction coefficient, the electric car needs to get more wide tuning. Let me show you. This is the curve, the tuning that combustion car can do it. This is the normal. When you move, you also can get a 90-degree turn. But in the case of the electric car, it's more difficult to get manage the turns of the electric car due of this friction coefficient with additional load of the car. Okay, so for that reason, this is a problem with the alt battery that we include in an electric car. It's not a good thing when you are traveling this. I don't know if you one time, I don't know, travel a really, really loud car, when you put a lot of things inside of the car and you try to travel and manage the car, it's not really easy, get the turns, okay, it's difficult. And this is the natural way to travel electric car, even if you have nothing more than you inside of the car, okay? And also the battery, I don't know if you check your cell phone, your notebook, this get heat. So this has heat inside because the battery naturally get more heat. It's not too much like a combustion motor, but it's necessary to cool down the batteries. to get all the energy possible in the electric motor and not in the head. So we need this small radiation to get inside cool air, and then, or in this case, liquid, cool liquid, and then the heat liquid here. It's really small. You can see here the size of the wells. It's not too big, but it's necessary, okay? And also the battery, we continue talking with the battery. The battery change the gravity center of the car. Is more close to the street, to the floor. So this is a good characteristic, okay? We have two bad characteristics with the battery, but this is one that is good. Because if you have the gravity center more close to the floor, to the street, the stability of the car is better. So the battery also works like a structural support, okay? So, okay, that is good for the battery, but the rest of the things are bad for the battery compared with the combustion car. The combustion car, the gravity center is more higher because the weight of the combustion motor is really significant and is upper than down of the floor of the car. Okay, but also we have some characteristics that the combustion motor has that electric car no. And this is, I don't know if you know about it, is the gas, the gases, the residues of the combustion. When you have the combustion, you have a lot of gases that is not good for the combustion, is the waste, toxic waste of the combustion. So this toxic waste need to go with a catalytic converter, then go to the silence, and then go in the ambient. All this part is necessary in the combustion car, and it's not something similar in electric car that we can compare. So this is a bad point for combustion car. And also the dynamic power, the control of the dynamic power is really better in the electric car. We're going to see inside. So this is the engineer inside of the electric car. It's only a simple transmission. It's only these wells, these two wells. This is the converter. Let me show you. This green one. Look, this is the green one here. This is the green one here. So this is the converter that we say that is the brain of the electric car. And this control the, with cables, the motors, and the motors do whatever the converter said. And this motor move this engine that is simple transmission, and this engine move the axis of the wells, okay? This is how it works. But the transmission of the combustion is really complex. We have different discs. You know, if you have mechanical transmission, you can change the march in the car, 1, 2, 3, 5, and reverse. And you have automatic transmission. The inner car is more complex to explain that transmission because it has more additional system with what is the name? With the springs, to do the automatic transmission, blah blah blah. But this is really complex. It's not 2 or 3 engines. It's more like, I don't know, a lot. You can see here. So this is a bad point because this is difficult to repair, to maintain, etc. And we talked this before. The brain of this simple transmission, every disc can do it, is doing by the inverter. The inverter can do in the different march, the reverse march, I don't know, whatever you can do it with this, the brain of the electric car do it, and do it with electric system. Do it with electric communication, with the electric motor, and in an electric way, the converter or the inverter, to get the same name, the inverter get this complex control of the vehicle, okay? So an additional characteristic is that the electric system has instantaneous control of the torque. We remember the figure of the graphic of the torque. And the combustion has really slow response in dynamic control. For that reason, the better car is the racing car Formula One, and the more normal car in the electric motor has really similar speed with Formula One car. For that reason, all electric cars that you can see in the street has a limitation of the instantaneous torque control. So if normally we have something like this, you know, we have this torque, so this speed, and we can change here really fast. The all electric car in the street has an additional limitation you can add here in the way to control, you know, the brain. Whatever you want to do, you need to put in the brain. So we have limitation of the speed change. So we go more slowly and then go to the same. So this is additional slower speed, and also faster than this, but not too fast like the normal electric vehicle, because you can see in the video, if you remember the video, it's not good. Okay, it's not good to have something like that in the street. You can get a lot of accident car, okay, with the people manage that speed. So we have an additional limitation of the change of the speed here. With only in the way to control, we add limitation for the motor. And also, if you remember, the motor is really silent, so we add in the way to control, we add some harmonics to get sound in the motor. For that reason, the person in the street can hear when the car coming. For that reason, they can avoid the car and avoid accident. So that is some additional that naturally the electric car doesn't have. Okay, continue. And also, one additional characteristic of the motors, of the engineer of the electric vehicle, is we have regenerative braking. We can charging our batteries when we are braking the car. Okay, so how works the regenerative braking? We use the motor now like a generator. For that reason, the better cars, instead of use induction motor, use synchronous motor. Is better for the regeneration. So this works as generator, and the generator, the converter now work like a rectifier and take the energy from the generator to the battery. So the AC to the C and the battery charging. Okay, so the electric car only needs one pedal to driving, only one. This second is the emergency braking. We don't need to use this to have a braking to stop the car, because this only control the speed of the car. If you are not pushing, the speed is null. If you are pushing a small, the speed is increasing. If you go out the feet of the pedal, the speed is slow, okay? You don't need to put the brake, it's instantaneously. Now we can check how expensive is the travel in the different car, okay? How expensive is the energy that they use and the kilometers that you need to record. So in electric car today, you spend, okay, this is in US dollars, 0.03 US dollar per kilometer. In the case of combustion, you need 0.1 USD per kilometer. So this is almost, or the combustion is almost 3 times cheaper, 3 times expensive than the electric car. Or if you can see from the other side, the electric car is 3 times cheaper than the combustion car. So it's a point for electric car. So in general, okay, this is in Spanish, I'm going to translate. In general, the comparison is electric car has a high behavior, has high dynamic response, is silence, has not really noisy, has low maintaining and travel costs. It's really easy to have maintenance of the electric motor because the engine is really simple. It's more secure because the gravity center and other characteristic is better. Also, if you have a really fast dynamic response of the motor, you can control almost instantaneously the vehicle. If you need to stop right now, you can stop right now. It's instantaneously, okay? That is a problem. You need more security, you know, to, I don't know if you know this. It's a good point, but it's a point that you need to take care. If you are here, excuse me for my, if you are sit in the car, imagine that is seat, this is the car, okay? And you need to stop instantaneously, you're going to do this movement. And this movement up, front and back, is a problem in your neck. So for that reason, you need a really special or really good, security system, okay? Usually, in some cars, they have 4-point, like a formula or racing car, 4-point security system. But also with 3-point security system, that is the normal security system, okay? You know, 3-point security system is 1, 2, and 3. Also work, but need to get a really good system here to blocking, to not get this neck problem in your body, okay? So it's really good to have a really instantaneous control to, if you want to break down the car and stopping in this moment, you can do it. It's not the same in the combustion car. If you want to, if you are trying, if you are in the maximum speed and you need to get down the speed really faster, it's not really possible in the combustion car. You need some meters to stopping. But in electric car, if you are in the maximum speed and you want to stop here, almost here you're stopping because it has some roses. But in the in combustion car, if you are in the maximum speed and you want to stop here, you need to stop here. You need more space. For that reason, you need to get some almost 2 meters distance between the cars in the highway because you need these 2 meters to stopping. Here is less than 1 meter. It's really small. But for that reason, your neck do this move and it's not good for your body. So you can solve this problem using a correct security inside of the car. Okay, so it's more secure and the transmission of the velocity is really simple. The good thing of the combustion car is really easy to recharge the car, recharge the fuel of the car, and the energy used in the car has high density. All these points are good points for the conventional combustion car. The disadvantage of the electric car is that it's weight. Even if you have nothing inside, it's really weight, because remember the battery has weight because it has a lot. Okay, one battery has not really weight, but 7,000 batteries weight. Has a lot of time to get full charging, and it's expensive. Even now, it's expensive. It's possible, it's accessible to people, but it's not like, here in Chile, you can get one car by $10,000, a combustion car, but you cannot find an electric car in $10,000. You can find an electric car in probably $20,000. Okay, it's not depend of the person, but it's more expensive than a conventional car. It's possible to get one, yes. You can use, yes. It's reliable, but it's expensive. You need to consider that. And disadvantage of the conventional combustion car has slow dynamic response of the engine, has complex transmission system, and you need to do a system to free the gases, toxic waste of the combustion. Okay, so that is the main difference, and that is why we want to move all combustion to electric car. And that is the point here toward the point we need to solve to get more electric car in the street. So that is my presentation. I don't know if you have any question.
Yeah, we have some questions here in the chat. The first one is from Hanieri. He asked if it's possible to think a Tesla will be any cheaper in near future, or the technology is really that advanced when we compare to other electric cars.
Yeah, I think yes. I think the cars, electric car, will be more cheaper in the future, and also the technology. Even now, the cars that Tesla are producing has not the last technology. We are trying new technology. The researcher in the university, in the center of researcher, developing more efficient converters. We need to use better energy because electric energy is really bad to storage. So we need to think ways to use more efficiently the energy, or more efficiently the energy, reducing the losses in the converter. You know, the electronic has also losses. Where is this one here? These, I don't know, EGBTs, electronic part has also their own losses. So if we reduce the losses here, we can use more energy in the motor. So for example, we reduce the losses here, and we can add 1% efficient additional. You say, okay, 1% is small, but 1% means, for example, 50 kilometers that you can add with the autonomy of the car with the full charging. So that means if you have a lot of problem today with the electric car is the people that has the car say we have to, I don't know, 10 meters, 50 meters, or something like that, from my house to the car, and I cannot get because I has no energy to record that last 10 meters, 50 meters. So if you reduce the losses here, I don't know, in the batteries, you change the batteries, everything is good, because today that is the problem. So yes, Tesla can even go more efficient, more technology in the future. I don't know if that is the question, yes?
Yeah. We have another one from Ian. Will electric cars completely replace the combustion cars in the future?
Yes, that is the idea. That's all the government today is working on that. The electrical, the idea is in the future, not too fast in the future. We start 2019. They start thinking in it, and they put some dates when they don't sell more combustion car. If you don't sell more combustion car, naturally this car is going to be reduced in the street. So in the future, probably, okay, in next 50 years, 2017, you can see probably only 1 to 10 combustion car when you have 100 electric car. So yes, that is the future. And it's working now. Okay.
Okay, we have another one from Arnaldo. What will be the impact of charging stations for electric cars on the power grid, and how can we prepare for this?
Yeah, that is really, really good question, Arnaldo. That is really good question, and we are working on that. We are working to use, electric car. And let me check if they're here a photo. Electric car is basically battery with wells, because has, I don't know, 90% of the basic of the car is battery. So it's battery with wells. And it's a battery that a lot of time is parking and connecting with the grid. So you can use this battery for improve the stability of the grid, to use this battery to charging or discharging, depend of the flow of the energy. So there are a lot of research in power system that is investigate how this, a lot of batteries in the close future connecting with the grid, how to affect the stability and how we can use this, knowing that it's going to connect in probably with a PV system, how we can connect this. And if it's better to use an isolate system for charging, or it's better to use in a connection with the grid system. So yes, it's a point that the power system engineer is analyzing. So electrical is not only a question for driver electrical engineer, it's also for, or power electronic engineer, it's also for power system engineering, because, okay, the power electronic engineer is going to see what happened in the car when it's moving and blah, blah, blah. But the power system is what happened when the car is parking and is connecting with the grid. Okay, yes, it's a point.
Nice. We have another one from Hannah. Even if faults are unlikely to occur, do we need to do a protection system for the induction motors in case the control fails?
Yes, of course, we can protect the system. And again, the protections come from the converter. For example, where is, probably it's better, it's basic here. Here, yeah. So what can fall in the car? Okay, for example, it's from the less possible to the more possible fall in the car is, we have the beginning, the less possible, the battery. The battery can fall, yes. The battery can damage their own and has not the same energy, so can fall the battery. So the kilometers that you can record with the car can be really small compared with the normal function of the battery. In that case, the only solution is to replace the battery. You cannot do nothing more. And probably you see this effect in your notebook or in your cell phone when the battery has not the same duration, the article that in the first weeks, I don't know, the battery has fault. But it's it's the less possibility in the fall in the car. The second thing that has less possibility to fall is the motor. The motor is really robust, but can fall? Yes, can fall. But the fall normally is produced by the bad control of the inverter. And this is the most piece of the vehicle to get a fall. There has a lot of power electronic inside. And for example, usually we use a multi-level inside of this inverter. I don't know if you know something about power electronics. I don't know what is your level of expertise. But multi-level, in general, the inverter is something like this. You have DC energy, and you're going to change in AC, changing the DC null, DC null, DC null, okay? And in the mean well, this has a different DC continuous. So in AC, you have something like this. Yes. So the mean value of this has something like this. So has a lot of harmonic, but the fundamental is sinusoidal and has this characteristic. So that is how work an inverter. The multi-level inverter, the only difference is that you have DC, but inside of the inverter, you produce different DCs, okay? Like you divide this in different DCs. For example, this is a 4 level. This is a 2 level. This is a 4 level. We have null, the third part of DC, two third part of the DC, and the full DC. So in the AC, you can get something like this, that this has less harmonics, okay? And it's better for the engine of the motor, okay? You extend the life of the motor if you have multi-level instead of two-level, because two-level, this dB in DT that you produce has a lot of problem inside of the insulation of the, what is the name in English? Of the, coils, yes, sorry, inside of the coil. So when you have multi-level, you have more parts inside. For example, I'm going to do a classical flying cap, I don't know, multi-level. This is one phase. And this is the output, and this is the neutral point. So you have more switches that can fall, and if every of these fall, you have not more multi-level, you need to reprogramming the control to detect the foul and say, okay, don't use multi-level because we have a foul, so use two-level. Because two-level is still working in the motor, you can still control. You need to ensure that if something foul here, you need to ensure to the conductor or the person inside of the vehicle that you are still able to control the motor, because if you are not able to control the motor, that is a really problem with the life, with the person life, okay? So the person that is going to programming the control of the system, the control of the brain, is they can add a lot of security code to ensure, okay, if foul one level, use two level. If foul, I don't know, one phase, use two phase. Reprogramming this to use two phase, so, okay, this is not working fine, but it's able to conduct the car to a parking when you can review the car, or you can change something. You need to additional system to ensure that if something foul, you can almost conduce the car to a safe part, okay? And that is able in electronic. That is not able in combustion. If the car foul in middle of the highway, you stay here. You cannot move, nothing more, okay? But you are able in electronic, using electronic, a control of the power electronic, able to do something to, I don't know, move a little the car and wait until someone comes to repair. Even depend of the foul, you can still doing the conduction for, I don't know, weeks until you get the reparation. And you need to consider that if you are a conduction in foul condition, okay, the life of the motor or the life of the converter is reducing, so the reparation is going to be expensive, okay? More expensive than if you get the foul and instantly go to repair the car. I don't know if that responds your question.
I think yes. We have other question from Pedro. He's asking if there is any prototype of electrical car with solar panels on it.
Not yet, but yes. Okay, I'm working in a project with the government of Chile that is including a photovoltaic panel in the car. Okay, we have a traditional electric car that you can build here in Chile. And here, they are not. We have not Tesla here in Chile. Tesla is not coming to Chile today. It is possible in the future that's coming. But we have Hyundais, we have Nissan, Volvo, I think, or BMW, but has not Tesla. So we are put panels flexible. You know, we have 2 or 3 different photovoltaic panels. One is the rigid or the solid panel that you use in the roof, and one is flexible that you can, I don't know, flex the panel a bit, and you can use in things like, for example, the cars. We use this panel here in the car, and put here and put here. Let me show you, probably it's more interesting for answer here. Let me show you the first research of this. Let me check. Esta. Okay, here. So we have this research. Let me check. And this, this is how work the normal car, and we add photovoltaic. Here we add the solar and the charger without intervening the normal car. So that is the challenge, because if we can access to the car here in Chile, we not produce car, we come the cars from other countries, so we cannot only in a specialty company. So the first work was, okay, add some system that is work with the traditional inner of the car. So we have this solar radiation here in Chile from different years. So we have the evolution of the solar energy, and we have here the different capability of the solar energy. For the blue one is the summer, the purple is the spring, the yellow is the winter, and the red one is the autumn. Okay, so we have different energy. In this case, is for the center region, Santiago, Valparaíso, I don't know, Rancagua, that is the more close to the capital of the country, because in the capital is where more electric car. So the study was focusing that, and we get some. Let me show some. Okay, this is the analysis of the panel energy in the winter. We get only the worst and the better conditions, summer and winter, because the other is in the middle. So we get, for example, the energy that the kilometers and energy that you can improve in different conditions, and in the end, we get some with different, six case of conduction that you need to analyze to see if not only in highway, not only in one case of conduction, you need to have 6 different cases that is normalized. There are normative tip that you can see and review what is this study that you need to use to prove the battery system. This project is to improve the battery, helping the battery charging with the solar energy. So with that, in the conclusion, we get that there are around 3% of the additional energy disponible in summer, and around 1% in the case of winter, that is the worst, where is a lot of cloud, blah, blah, blah. So yes, responding to your question, yes, there is not today in the commercial, but there are a lot of persons working on that, and probably in the next year, or probably really closing, you can see a photovoltaic and cars including. Okay, this is the results are not the optimum, because if you can get the inside engineering of the car, you can has better control, because you can use this inverter, so you cannot add an additional inverter. Let me show you. The problem here, the limitation that has the limitation is you need this inverter. You can see here this inverter. So instead of use this inverter, so We are working in a research that simulating that we can access to this. We are working in a simulation that use only one inverter to control photovoltaic, battery, the motor, and the grid side. So we have 4 ways using only one inverter. So that is one of my postgraduate students is analyzing. Okay, so answering your question, yes. In the future, I hope we can see more of that.
Nice. So we have 2 more questions. One is from Isaac. He's asking, how can IEEE support research about electrical mobility, and what is the impact that IEEE have in this area?
Yeah, I don't really know how IEEE support these researchers because I never get support from research from IEEE. But IEEE support, for example, a student traveling to the conference, a student travel presenting the work, and that can help us to present the work our student doing in this area. So I think probably that is the way that IEEE support. And of course, there are a lot of publication in Power Electronic Journal or Power Application Journal or even in Industrial Application Journal, when you can see the papers about electric car and you can study that and review that and check and work in that. You can interchange the communication, the researcher and presenter in the conference. There are a lot of conference with a special section only with electric car. So I think in that way, probably they can support that. And the other question is what impact?
Yeah, the impact of IEEE in the area. But I think
it's in the same way. So I don't really know very much about the relation with the impact, only with the review papers, conference. But and the possible of scholarship for a student to travel to the conference to see what the other researcher in the other part of the world is doing, to learn what they're doing, and to present their work. So I think that way is really good.
Okay, that's really nice. So the last question is from Luan. He's asking if there is any resistance from the petroleum industry against the increase of electrical mobility.
That is one thing probably I don't should say, but you don't say to anyway. Okay. It's yes and no. It's like, the natural electric energy, aeolic, photovoltaic, hydraulic energy from electric energy, the hydraulic central, instead of thermal. I don't know how it is in Brazil. Brazil has also a lot of water when they can get electric energy. Chile also. So it's the same question, There are a lot of, let me check. In Chile, we have, I'm going to start with this example because it's similar what happened with the electric car. We have the hours of the days, okay, and we have the electric energy that we need. And usually this is the electric energy covered by hydraulic central hydraulic generation. This is the covered by the aeolic, and this is photovoltaic. And usually the necessary energy from the house and everything in Chile is in the first hours of the morning, is something like this. For example, something like this in an example. So this is covered full for the hydraulic. The difference is hydraulic, aeolic, and photovoltaic. The cost of the energy is null because you don't need to use, I don't know if you know how work the commercial energy, electrical energy, I know if you know how it works, but you have the price of the moment when you can sell and buy energy is in the paper because the energy, you cannot change the demand. Okay, the demand is stability. But you can sell, for example, if you sell energy here, the cost of the energy in that point is null Okay, not really null, but only the operation cost that is really slow, because has not combustible you need to buy, so the cost is null. The cost of the energy in every point is the cost of the last central inside of the system. So in this point and this point, the cost of the energy is null, because only has the operation cost. The eolic is the more expensive operation cost, but it's still really close to null. But this, you need additional energy that is not from cheaper energy, and this has from thermal energy, combustion, coil, no, it's coil. Carbon, coils, etc., whatever thermal energy. And this energy is really expensive. So if you sell or buy energy in this point of the operation, you need to pay really much. For example, an hydraulic generator that sell energy in this time, because you need to cover this point, they're going to win all this money, okay? Because they are selling energy to the system, and the sell point in that point is expensive. When they sell energy here, they cannot decide when they want to sell or not, okay? The government decide who go first, second, third, is every time from the cheaper to the expensive, okay? And to cover the demand. So in this point, the hydraulic central is only cover the operation cost, has not winning nothing. But in this point, all these are winning. And this point, the central thermal central is only cover the fuel and the operation, so it's winning nothing in theory. But additional of this, every central that is registered in the system can sell or buy energy, and the cost energy that is transient in this point is the cost of this that the government decide, okay, because it's the last one energy. For example, one thermal central that is not working, say, okay, I'm going to sell, it's like, bolsa de valores, what is the stock exchange, that? The stock exchange, when you buy and sell bonus, okay? So this one thermal central that is not working in that point, say, okay, I'm going to sell my energy. And for example, other thermal central say, okay, I'm going to buy your energy. And for example, if, I don't know, it's a saucer, or whatever happened in the end, or say a festival, or I don't know, whatever, and the energy go up than this line, if you buy energy here, you can say, okay, now you need to put your energy here, and the cost is higher, but they can only get this money. I don't know if you are understanding. So if you, it's like it's literally like a stock exchange, but with energy, okay? And the stock price fixes with the system in that moment. But if you sell energy here and you are not using, you need to use that energy in the next time that one central is going to use. For example, this thermal central, I don't know, we have 3 thermal central. The first one is this, the second is what sell here, and the third one is the need to go inside here to cover this time. So this central going to receive this money, but instead of produce energy, they say, okay, I buy energy from this central, so this central need to go inside, but he received this energy. You understand? So this central is going to lose money because sell energy is cheaper and need to produce energy when it's expensive. You understand? But they cannot say nothing because they sell energy to the central. So in the paper they sell and buy energy, but in the reality, only the thermal that the government said is going inside. So the person that has the own of this thermal central don't want the hydraulic or aeolic or photovoltaic central go in the system, because when this central is in the system, the cost of the energy is null. Okay, so they patrocine the green person that say no more hydraulic because we need to conserve the biosystem, you know. But this is if you see who they give the money to this person to go in the street and to do the performance, to say no more hydraulic to destroy the south of the country, the person that pay for that are the owners of this company. But they start to buy hydraulic, aeolic, and photovoltaic system. So when the demand increase enough that you need the hydraulic, the aeolic, and the photovoltaic, you even that need to thermal. They say, okay, now we don't need more Protestant because we are in the same situation, because the demand naturally in a society, the demand of the energy is increasing. Okay, so they are waiting until the demand is enough to ensure that the thermal is still working. So that is how it works in the power system. And in the case of electric car is similar. The person that has combustion, the petroleum system, are starting buying all the necessary system of the power in electronic, or I don't know, to ensure that when you need to sell car, they start to sell that, or buy the charging station, because they know that electrical need a lot of charging station, a lot of way, and they going receive money for this. And remember, the petroleum is not only uses for the fuel of the combustion car, has a lot of secondary things that you get from the petroleum. Even some medicine you get from the petroleum. Okay, so yes, they are waiting. They are breaking the slowing advance of the electric car to ensure that when the full electric car is in the full of the person in the country, they can get even that a lot of money. Okay, so it's not possible to stopping, but they are trying to go slowing. I don't know if that answered your question.
I think it is. Nice. So we have one last question from Roberto, and he's asking, how works the calendar of maintenance of electric car? Like, is this, in this case, we have less components to review, so it's less expensive or not?
Yes. Okay. That is a really good question, because it's a really good point for electric car. Yes. Compare, the more expensive maintenance of a car is the diesel car, and then the oil car. The diesel is more expensive because the diesel has more contamination, more waste than the oil car. So the diesel is the more expensive, then the oil car, and then the electric car. But it's like this. Let me show you. You have the price, and the cars. We have electric car, we have the oil car, we have the diesel car. Okay, these two are combustion car. So the electric car is something like this, and the oil car is something like this, and the diesel car is something like this. And if we compare the efficiency of the vehicles, we have here by kilometers. Usually it's liter of combustion by kilometer, but we have no liter here in electric car. So I'm going to put the money by kilometer. This is electric car. This is oil car. This is DC car. The only characteristic that to get this, we need to consider that DC car need to get in a steady state a lot of time to get this graphic, okay? Because we use in a city car, DC car is not really good, okay? Diesel is not good for short distance. Diesel is good for long distance. So we're going to consider that to do this graphic. So this has, sorry. I'm going to put in the other way. Kilometers with per money, okay? In combustion, using liters. Liters, okay, liters. So in electric, it's something like this. Compared with this in oil, is something like this. And compared with this, the diesel, remember, in long distance, is something like this. So diesel, compared with the oil, is better. Remember, to record long distance. If you use a diesel car in a city, it's not good. Okay, don't buy a diesel car for a city. If you're only going to use a city, because it has okay, it's expensive maintenance, but has more cheaper, because diesel is cheaper than oil. Okay, but electric is really cheaper than these two. Really, really cheaper. So electric car is win in both category. Has really low or cheaper maintenance, and even the maintenance is has not is longer. Okay, you need more kilometers before to review the electric engineer. You need, of course, 10 kilometers, 10,000 kilometers. 10,000 kilometers to review, because you still have some mechanical part, you know, the wheels, the pneumatic, I don't know, all remain of the cars, that is normal, the mechanical part, but not the engine of the mechanical motor. So it's really cheaper. It's only to check, okay, you don't need to check the oil of the system. You don't need to check the, I don't know, the braking liquid, because you don't have braking liquid in electric car. You have a electric system to brake. So you only need to check the wells, the, you know, the amortiguation, and the part of the car that is not relation with the motors. Okay, so it's really, really cheap. It's around, I don't know, in dollars, probably $10-20. And when you get something like the 3 times normal combustion car maintenance, you need to check this. And if you have some alert here that is produce a fault, but normally has not. So normally in a life of the car, probably if you have 5 years electric car, you need to check the maintenance of electric system 1 per year. Or I don't know, 1 per 2 years, depending on how many to use the car. So, and it's still that when you need to review the maintenance of the electric system, it's cheaper. I don't know, if the combustion car, you know, the cost of the maintenance is increasing with the years of the car, with the kilometers that you record. The electric car is constant. That is another advantage. So, yeah.
Okay, I think this was the last question. So that's it. I would like to thank you all for the presence, and thank you, Margarita, for the amazing class. And that's it.